Hello, how to make your own transistor. This video shows a working device. Use at your own risk. It can be dangerous. Here we see two terminals with a spark gap in between of them. Below those two terminals, there is an isolating layer which is non-conductive. Below that, there's another plate which acts as a capacitor and which is our trigger. I touch the trigger, so the capacitor, with my leg. So when my finger touches one of the two electrodes, the capacitor is charged to that voltage, which activates and deactivates the circuit. Later in the video, I show two designs, version 1 and version 2. The version you see here is version 1. This one is more complex in working, but it's a lot more efficient and can handle much higher power with a lot less energy loss. In version 1, you can see if your version 1 might need some tweaking to work properly, because otherwise it might just act like a version 2 or not work. But you can see if you have a version 1, then you need to charge it with the voltage of the terminal which is not above the capacitive plate to activate it. The other one will deactivate it. Version 2 will activate when you charge it with the voltage above the capacitive plate. Now, I will not completely explain the version 1, perhaps I will in text. Both I will not completely explain now, because this video I want to keep it short and it's all unscripted. So that will be really chaotic if I try to explain it. Here you see that the materials I use were just crappy. I even did use my non-conductive layer was actually slightly leaking, which degraded my the effects of it quite rapidly. The more it became worse in being non-conductive, the worse it started to work. However, you can use it with bad materials. Now you see version 1 and 2 are basically the same. We have a left and a right terminal with a spark gap in between them. Then below that there is a non-conductive layer. The only real difference is in the capacitor underneath it. If you can see, the capacitor on the version 1 is almost only below the left terminal. It can go behind it and just slightly more to the right than the terminal above it. However, it will not pass half the distance from the left to the right terminal. Version 2 also can be slightly underneath the right terminal. The version 2, you could see it for people who are completely new to these things and can't visualize these things for themselves. You could for now see version 2 as if the capacitor pulls in the voltage from the right terminal to the left terminal. It pulls it to the capacitor, which causes it to just be close enough to the left terminal to move there. It just gives it a little more force to jump over. That's a more simple way of seeing how it works. Version 1 is too complex to explain for now. In here, it uses a lot more of principles. Now, this spark gaps, you can make the direction of energy flow any of the directions you want. You can even connect it to AC, because it isn't an actual diode-based transistor. Most transistors on the market are diode-based. This one isn't. You can make it work as a transistor. However, you just will need to add another capacitor, and then you can make this work like a diode. I might explain that later on text or perhaps with a drawing, but not now. So why you want it? Of course, you can make computers, frequency generators, all those stuff used in school projects, or just show how our transistor might work, because it functions quite much the same, despite that it's somehow different. So why I made it? I just wanted to know how a transistor worked, and I decided it was more easy to just design my own transistor than to search online how a transistor should work. Because if I search online, you never get a full understanding of it. And if I just decide from this is what a device should do, then I can just visualize it, and then it will work. And so I just visualize something to for this specific transistor, because I made more designs. However, these ones are the most simple ones, and these and the most normal ones basically. So this is how these transistors, how I came with them. I just wanted to know how transistor worked, so I just came up with an idea, visualized it, and made it. I didn't actually know how transistors fully worked on a deep level because I've never really been able to experiment with the materials that an actual transistor has inside of it. So I do not know if it perfectly matches the actual, well, an actual transistor. On physics level, it's probably somehow different because I don't use actual diode-like devices in here.